If you asked me to name someone who exemplifies scientific thinking, the first name that would pop into my head would be today's guest, Richard Dawkins. A professor emeritus at the University of Oxford, Richard Dawkins is both a distinguished scholar of zoology and evolutionary biology and a remarkably successful popularizer of scientific ideas through his best-selling books, including The Selfish Gene and The God Delusion. If you don't think like a scientist, I'd suggest you stay out of his path.
There's no evidence, and if you want to believe in something positively, you need positive evidence for it.
Welcome to People I Mostly Admire with Steve Levitt.
In 2017, the Royal Society, the United Kingdom's Academy of Sciences, conducted a public poll asking readers to name the most influential science book of all time. The winner was The Selfish Gene. That book, published in 1976, starts from a simple premise. Genes, not organisms, are the key players in evolution, and shows how this one idea can make sense of a remarkably broad set of phenomena we observe in the world. Now, I suspect Charles Darwin, Isaac Newton, and a handful of others might have good reason to disagree with the result of that poll, but there's no denying the enormous impact Richard Dawkins has had. I have to start with a confession. Before last week, I'd never read your book, The Selfish Gene. I have now. And I was quite shocked at how eye-opening the book was for me. I've spent a lot of time around scientists. I know the basic mechanisms in math around natural selection. And the book is nearly 50 years old. I thought I knew what the book had to say, but I honestly didn't. And I suspect that many listeners suffer under that same fallacy. So I'd like to start by talking about some of the big ideas in that book. And in particular, you make a sharp distinction between replicators and the survival machines they live in. Could you explain those two concepts?
A replicator is anything that makes copies of itself, and the obvious replicator is DNA. So DNA makes exact copies of itself with occasional mistakes, and that means that it goes through an indefinite number of generations. So there are genes in you which perhaps were in existence 10 million years ago. So a replicator is something which is potentially immortal. And the way they replicate, in our case and in the case of most of the animals we're familiar with, is they program bodies, which I call survival machines, as robot vehicles which carry them about and then pass them on. So a successful replicator is one which is very good at the process of embryology, making bodies which go on to pass them on in reproduction to the future.
Now, that's a very uncomfortable idea because I think of me as being important and having agency. But reading your book makes me think I should really downgrade my sense of self-importance. I'm really just a fancy tool that allows these strange little replicators to replicate.
Well, you are, but on the other hand, you also are the agent that actually takes decisions, does things, that sees, hears, acts, walks, talks. Genes don't do that. They are carried about. They don't have agency. They don't have the sort of cognitive apparatus that you as an animal do have.
Evolution isn't good or even purposeful. It just is. And I think because as humans, we're the end product of hundreds of millions of years of evolution, we tend to ascribe positive value judgments to evolution.
I mean, it is true that it just is. On the other hand, while being is, it fashions for its purposes machines, which is us, which are very purposeful. So if you watch not just a human, but any animal, it will appear to be doing purposeful things in order to achieve its own survival and its own reproduction.
One of the most striking chapters in The Selfish Gene is chapter 11 on memes. And I've often heard people say, oh, Richard Dawkins created the term meme. But I always honestly thought of memes as being somewhat trivial because now they're very much associated with internet fads. When you mean a meme, you mean something like Darwin's ideas about natural selection, right?
Yes.
It's an idea he had, which then is transmitted from person to person, generation to generation.
Or it could be a clothes fashion or a hairstyle fashion or something more trivial like that.
But really, in your book, you're making an incredibly deep and profound point that DNA and memes, they seem on the surface to have little to do with one another, but once one accepts the centrality of replication, they are, in some sense, just different ways of accomplishing a similar task. I'd love to hear you talk about that insight.
To me, the fundamental unit is the replicator, and anything that replicates itself accurately is potentially the basis for a process of evolution by natural selection. I just wanted to make the point that DNA is not the only one. If we ever discover life forms on other planets, we can expect to find that there will be replicators at the base of their evolution, but they probably won't be DNA, it will be something else. And in the concluding chapter of the first edition of The Selfish Gene, I cast around for another example of a replicator. I wasn't then aware of computer viruses, otherwise I might have chosen the computer virus as my analogy. So I chose instead the unit of cultural inheritance, the meme, and thought that in principle it's possible to regard a unit of cultural inheritance as something that replicates itself and spreads, rather like a virus, through the population, or passes down the generations, rather like a gene. And so I wanted to detach what I was saying from necessarily being associated with DNA. Any replicator could perform the same role in an evolutionary process. So the meme was serving that purpose for me at the end of that book.
Reading your work reminds me of just how similar the tools and the worldviews are of evolutionary biologists and economists, especially the older Chicago school economists are really aligned with your approaches. Did you have the chance to interact much with Milton Friedman or especially Gary Becker when they were alive?
I think I might have met him, but I don't remember very clearly. I certainly never interacted with Milton Friedman. It is true that economic ways of thinking do enter in a rather big way in evolutionary theory. I believe that the economics of Adam Smith perhaps has quite a lot in common with the economics of evolutionary theory, but I'm not very well versed in that.
About the same time you were writing The Selfish Gene, Gary Becker was writing a book on the economics of the family. And a lot of the same trade-offs are at play. So you talk in The Selfish Gene about the quantity of children and the trade-off between more offspring and higher investment, and so better outcomes per child. And in the economic sphere, Becker was arguing the same thing. And I think he was actually getting even more negative feedback because he was applying it so clearly to choices humans were making than you were, because your book really was centered more on animals. It's really striking to me, the parallels between those two lines of inquiry and clearly game theory. So economists think very much in terms of game theory, and so much of what's done in evolutionary biology is based on these evolutionarily stable scenarios. And so I have found that it's easier and more natural for me to talk to an evolutionary biologist than any other kind of scientist.
I get that. There are, of course, important differences. I mean, in human economics, you're talking about utility, which has something to do with human motivation. When we do animal evolution studies, we're not talking about conscious motivation at all. We're talking about the sort of as-if motivation of genes. But when you look at, for example, the work of Robert Trivers on parental investment, following on from R.A. Fisher's ideas, you put yourself in the position of a parent, for example, as if deciding how much economic goods to endow onto one child as opposed to another, or one child here and now as opposed to a future child not yet born. The economic idea of opportunity cost comes in very strongly in evolutionary theory. So the opportunity cost of investing in this child now is measured in lost opportunities to invest in future children who are not yet born, or possibly present children who are competing directly.
Some of the most interesting intellectual conversations I've ever had were with a gentleman named David Haig, who I'm sure you know, and his discussion of the games that were being played between the unborn child and the mother who was bearing that child. That was really eye-opening for me.
David Haig is one of the most brilliant theorists in evolutionary biology today. He took sort of the ideas of Trivers I've just been talking about and applied them to pregnancy. and the conflict between mother and fetus, which explains so much.
Yeah, because things like preeclampsia, his explanation is that what's good for the fetus is not necessarily what's good for the mother. And so consequently, there's this battle going on where the fetus is shooting out hormones and things, trying to overpower the mother. Now, it can't go too far because it doesn't want to kill the mother. But my God, I don't think David has ever written a popular book, but I'm not sure why, because it is really amazing stuff.
It is amazing, and it's disquieting to some people because if they think in emotional terms, it's rather an unpleasant thought, but it is really inescapable when you think about the evolutionary theory.
Can I ask you a more offbeat question about the selfish gene? One big difference between that book and modern popular science books is that in The Selfish Gene, you devote a lot of pages to presenting in detail the arguments of other scientists who you think are confused, and you're critiquing them, and you name them by name. E.O. Wilson, even Trivers, you criticize at various points, Conrad Lorenz. I think contemporary popular science writers, they don't bother. They just tell the story they like, and they don't deal much with countervailing views. Have you noticed that difference yourself?
John Maynard Smith, in writing a review of The Selfish Gene and The Extended Phenotype, my second book, made a rather similar point, which is that The Selfish Gene doesn't really fit in with the conventional view of a popularization. At the same time, it's written both for lay people and for professionals in the field. An aspect of that is what you're talking about, which is mentioning other authors and in some cases criticizing what they say. You're probably right that so-called popularizations of science mostly take existing orthodox science and make it palatable to the general reader, whereas what I was doing was sort of criticizing existing science, at the same time writing in a style which could be understood by the general reader.
We'll be right back with more of my conversation with evolutionary biologist Richard Dawkins after this short break.
I'm sure you remember the TED Talk you gave in Oxford back in 2005 about how strange the world is. I happen to have been in the audience that day. It's the only time that I've ever seen you in person that I'm aware of. And just to set the stage, the crowd was absolutely buzzing as you came on to speak and explosive in their applause afterwards. And understandably, because you managed to cram much of what is interesting about science into a 20-minute talk. As I listened to you that day, one thought kept on running through my mind. And that thought was, I feel really sorry for the next speaker. This is an absolutely impossible act to follow. You know what the sad part of the story is? I was the next speaker, unfortunately. Whoever set that thing up set me up for failure by making me go up on stage. And I remember walking on the stage and like no one was paying any attention to me. They were still between themselves talking about how amazing what you had done was. And as I spoke, it was one of the most distracted and least interested, almost hostile crowds I've ever faced.
I'm sure you're exaggerating.
No, actually not. I mean, part of the problem was my topic. So you had just explained the wonders of the universe boiled down into 20 minutes. And my topic that day, I was showing detailed statistical evidence that children's car seats empirically provide more or less no more safety than adult seatbelts.
I'm interested in your car seat point, and I have read an economist who said that the best way to improve road safety would be to abolish car seats altogether and have a dagger sticking out of the middle of the steering wheel straight at the driver's heart. And I see the point.
That's called the Peltzman effect. It's an interesting idea, but there are countervailing forces, right? By putting the dagger there, pointing out of the steering wheel, even the most minor mishap causes terrible outcomes. And so you need the extra care that people take to override that. And it turns out in practice that most of the time, that's not really true. Culturally, we've been so brainwashed into believing that car seats are the most wonderful thing ever that when I say they don't work, people get very upset. That was both a very small topic relative to the wonders of the universe, but also, interestingly, a topic which every time I talk about it, people hate it. This is, in some sense, a lead into talking to you and the reactions you've gotten when you've argued against religion in books like The God Delusion. You have this enormous amount of research and thinking you've done around natural selection, and then you took a detour to really take on religion. Were you prepared for the outrage that your book generated?
I think you're exaggerating the outrage a bit. Perhaps I just wasn't so aware of it. And it wasn't that much of a detour, because I think that the hypothesis that there lurks a creative intelligence at the base of the universe is an amazingly exciting scientific hypothesis. I think it's wrong, but if it were true, it would be very important. It's a totally different kind of universe that we'd be living in, and therefore it's a very important hypothesis. And I regarded it as a competing hypothesis to the true one, and therefore I wanted to oppose it.
And I know you've made your case 1,000 times before, but just to make sure we're all on the same page, could you do it one more time for the listeners? What do you think the strongest pieces of evidence are that this view that there exists an all-powerful God is fallacious?
Well, first, there's no evidence for it. And if you want to believe in something positively, you need positive evidence for it.
Okay.
But I think there's actually rather strong evidence against it, which is that certainly to somebody who's brought up as an evolutionist, the whole strength of the Darwinian theory is that it explains how complicated things that carry apparent design, can come about by non-designed means, by slow, incremental, gradual, step-by-step change from primeval simplicity. And if you suddenly, by magic, import primeval complexity into the situation, you're left with the problem of explaining where that primeval complexity came from. A God who's capable of designing the universe would have to be a supremely complex being, and therefore it would be a betrayal of the whole scientific enterprise, where what we're trying to do is explain the way things come into existence. I regard that as positive evidence against the God hypothesis. Theologians try to get away from that by saying, oh, we don't believe in a complex God, we believe in a simple God. But if he's supremely simple, he couldn't possibly do the things he's supposed to do, like design the laws of physics, let alone forgive your sins and listen to your prayers, that kind of thing.
I was raised outside of religion, and one of the things that has always been very surprising to me is how people can have complete and total faith in their own God and set of gods, but be utterly dismissive of other people's choice of God and gods. It's surprising, isn't it?
It's really quite funny that they know perfectly well that if they'd been born in a different country, they would be worshipping a different God, and yet they still cling to the God who just happens to have been the God of their parents and grandparents in their school.
It seems as one reads The God Delusion or your other books and writings on the topic, it's really difficult or even impossible to argue with you if one is thinking like a scientist. And presumably your critics, or the bulk of the world, who apparently doesn't agree with you because they believe in this God that you think is impossible, they're viewing it from a different lens. I know you've debated a lot with people on this topic. What's the typical counter-argument that people try to offer?
Well, first, when you say the majority disagree with me, the majority haven't read me.
Okay.
But I suppose a fairly dominant strand is to say that religion is comforting and consoling. And that's obviously a terrible argument, because just because something is comforting doesn't make it true. A lot of people just don't seem to be able to see that. Or they even don't care whether it's true. They just think it's comforting, and that's enough for them. There are scientists who are religious, often they're physicists, who believe in some sort of supernatural creative force, but don't subscribe to any particular religion like Christianity or Islam or Judaism.
So like Einstein would be an example of that, right?
I don't think even Einstein would know. I mean, Einstein used the word God, but he used it as a sort of metaphor for that which we don't understand. So when Einstein said, but he doesn't play dice, meaning that God doesn't play dice, he meant he doesn't think that the uncertainty principle is valid. When Einstein said, what I really want to know is, did God have a choice in designing the universe? He wasn't really meaning God. What he meant was, is there only one way for a universe to be? In other words, does it have to be the way it is now, or could you imagine alternative universes? But then there are some scientists who really do believe in Christianity or Judaism or Islam and go to church, go to mosque, go to synagogue. And I can't fathom them at all. One notable one is Kenneth Miller, who's one of the doughty defenders of evolution against creationism, and is very valuable he is because he has the credentials of being a religious man. And when I tackled him about this, he said, Richard, there's a reason it's called faith. Well, that sums it up for me. That is an absolute non-argument, but yet it is something that apparently convinces him.
I've shared your beliefs about religion for as long as I can remember, but I've never felt any need or desire to engage in a fight over it. I'm an atheist who says he's agnostic just to avoid ruffling feathers. So you probably hate people like me, right? Because I'm a big part of the problem in some sense, from your perspective, right?
Not at all, no. Some of my best friends are vicars and bishops. I like to engage in the scientific argument with them. I think it's a scientific hypothesis, which is a wrong scientific hypothesis, but a very interesting scientific hypothesis. So I'm not hating anybody at all. It is true that occasionally I felt a little bit resentful that I'm treated as though I'm unusual in being an atheist, when I know perfectly well that scientists are atheists, but they just don't say so. And therefore, when I go out to dinner with somebody and somebody makes a joke about perhaps we better not say grace because Richard's here, that I do a little bit resent because it suggests that I'm the only one around, whereas people like you, of course, I know perfectly well are there, probably at the same dinner party.
The movement in your direction is probably far slower than what you would hope for, but it is incredible, at least in the US where I've seen polling data, how quickly the share of people who self-identify as religiously unaffiliated, how that's growing.
Yes.
Last poll I saw was 29%. And I think if you go back even to 1990, it was in the single digits. In a universe in which the Western world has been predominantly Christian for 1,000 years, it's amazing how quickly an unraveling is happening on these dimensions.
Yes, and yet politicians in America are still very careful to invoke God in all their speeches. And so it's as though they haven't yet woken up to the fact that the statistics are going the wrong way from that point of view.
You've got a new book, and it's called The Genetic Book of the Dead. How would you describe it?
It's aimed at the same audience as The Selfish Gene. That's to say, as we were talking about earlier, it's aimed at both lay people and professionals. Its main thesis, I suppose, is that any animal, including us, can be read as a book. And what the book describes is the ancestral worlds in which the animals' ancestors lived and in which they survived and passed on their genes. So, in principle, a scientist of the future will be capable of reading the animal as a description of a whole series of ancestral worlds, not just one, because, of course, there are ancient ones and more recent ones and very recent ones. I call it a palimpsest. Palimpsest is a document which has been overwritten by later writings using the same parchment. So the animal is a book, but it's a palimpsest of writings from different ages in the ancestral past.
Maybe it's just me, but the new book feels like a kinder and gentler version of Richard Dawkins. Many of your earlier books were exercises in persuasion, trying to convince readers of a particular truth. And to me, at least, the Genetic Book of the Dead, it's more a celebration of the wonders of the world, a reverie about the incredible creatures and behaviors natural selection has produced. It has a kind of poetic feel to it. Is that purposeful on your part, or am I reading into something?
I'm very glad to hear you say that. I hadn't thought of it in those terms, but that pleases me. I didn't really think of my earlier books as being particularly polemical, but perhaps they were, perhaps they can be perceived as such. And certainly I think this latest book is not polemical. And I like your description of it as poetic. I'd like to think it was poetic.
And the visuals, I have to say, are unbelievably striking. It's a different experience than I've ever had with a science-related book.
Yes, the artwork is by Jana Lentsova, who is a Slovak artist and translator. I actually met her because she translated The God Delusion into Slovak. And she illustrated my previous book, Flights of Fancy, which is about flight.
There's so much of interest in the book, but one part that I found myself repeating to anyone who will listen is the story of the cuckoo bird.
Oh, yes.
I mean, since I was a kid, I've heard about how cuckoo birds sneak into the nests of other species, they lay their eggs, and they trick the other birds into raising their young. But there are so many layers to the story that I never understood or even imagined.
Well, it's an extraordinary story. What they do is, well, I'll tell what the European cuckoo does, Cuculus canorus. The female cuckoo earmarks for victimhood a particular nest. It's always, or nearly always, a nest of the same species as she herself was reared in. She steals one egg from the nest and then lays one of her own eggs. The baby cuckoo usually hatches first before the legitimate birds of the foster species. It then, in an astonishing act of murder, tosses the other eggs out. It has a special hollow in the small of the back in which an egg fits. And it fits this egg into the hollow and then shuffles its way backwards up the side of the nest and then tips the egg over the side, which of course kills it. Or if the others have hatched, it tosses the other chicks out.
This little cuckoo bird is, minutes old or hours old when it's doing this. It's literally the first thing it does.
It hasn't the faintest idea why it's doing it or what it's doing. It just does it. It's wired with a kind of clockwork mechanism that does it. It then is in sole possession of the nest, and the foster parent feeds it. Not always. In some cases, the foster parent is wise to it. And as a consequence of this, there's an evolutionary arms race between the foster parent species and the cuckoo species, and they each have evolved very striking adaptations to outwit and outcompete the other. One of the most striking, one of the ones that I discuss at length in the book, is egg mimicry. The female cuckoo lays eggs which look exactly like the foster species.
You have the most beautiful photographs of the nests. So there's the nest of the reed warbler and stunningly beautiful eggs, very complex patterns, and the cuckoos looks exactly the same, except a little bit larger. And then next to it, you've got another species of birds that the cuckoos victimize, completely different looking eggs, and yet the cuckoo's egg looks exactly like it. So my first reaction was, big deal. We see mimicry all over the place. But this is somehow deeper because the same species of cuckoos somehow have figured out when they put the egg in the one, it's got to look totally different than the other. And when I saw that, it stopped me in my tracks. So how in the world did they figure that out?
That's the most remarkable thing, and that's why I devoted so much time to it. The truth is that each female cuckoo only lays eggs in the same kind of nest as she herself was reared in. And what this means is that if you're a female cuckoo looking back at your female ancestors, you're looking back at a long chain of ancestors, all of whom were brought up in the same kind of foster nest, whether it's reed warbler or meadow pipit or whatever it is. So female cuckoos can be said to belong to a kind of race. They're actually called genties. Singular is the gens. So there's a gens of meadow pipit cuckoos, a gens of dunnock cuckoos, a gens of reed warbler cuckoos. So if there was some way in which the genes could pass down the female line only, you've got an answer to your problem, because it would mean that natural selection could be working on the genes of that female line, despite the fact that it's all the same species as defined by the fact that males who've been brought up in all the different foster species are mating with females. So males are indiscriminate with respect to the kind of female that they mate with, but females are highly indiscriminate with respect to the nest that they choose to parasitize. Now, as you know, sex in mammals is determined by the XXXY system. So a male mammal, a male human, has a Y chromosome and an X chromosome in every cell. And when a male makes sperms, half the sperms he makes are X sperms and half are Y sperms. Females are XX. All their cells have 2 X chromosomes. So when they make eggs, all the eggs are X eggs. When a sperm fuses with an egg, half the sperms are Y sperms, and they produce XY, which is a male, and half produce XX, so make females. Birds have the same system, except it's reversed. That's the point. In birds, it's the female who is the XY, and the male who's XX. It's not called X and Y, but it's the same principle.
That's critical, because otherwise you'd be getting 2 of the female chromosomes, and it wouldn't know which nest to lay it in.
That's right. The whole point of my chapter is the gene looking back at its own history, its own Book of the Dead. A gene on a Y chromosome looks back on a long line of, say, meadow pipit nests and nothing else for a long way back, or reed warbler, or dunnock nests for a long way back. So that means that natural selection could be working on genes on the Y chromosome to fashion the egg to look exactly like the egg of the foster species of this female line. And if egg coloration is inherited on the Y chromosome or on other chromosomes but is switched on by genes in the Y chromosome, then you've got an answer to the riddle which you raised of how it's possible for female cuckoos of the same species to mimic eggs of many different species. Occasionally, a female will make a mistake and lay an egg in the wrong foster species, and such an egg is likely doomed because it will not mimic the other eggs. And that's presumably how a new gens gets started. There is an interesting point that the cuckoos that lay eggs in dunnock nests, the eggs do not mimic dunnock eggs. Dunnock eggs are blue, and the cuckoo egg is not blue. It's obviously a totally poor mimic. And it appears to get away with it because dunnocks don't seem to have the discrimination to throw out cuckoo eggs. By the way, I'm deriving this mostly from the work of Nick Davies of Cambridge University, whose book called Cuckoo I strongly recommend it. And the idea of him and his colleague Mike Brooke is that the evolutionary arms race between cuckoos and dunnocks is a young arms race, and the dunnocks haven't yet had time to evolve discrimination against cuckoos, and the cuckoos haven't yet had time to evolve good egg mimicry. And presumably the expectation is that in another 1,000,000 years, cuckoos belonging to the dunnock gens will have perfected egg mimicry at the same time as dunnocks will have perfected discrimination against cuckoos. As you say, it's a very complicated story.
So you have left out one piece, though, which is how the cuckoos who want to lay eggs in the reed warbler nest, how do they know to go find a reed warbler nest? That seems like it would be a very difficult thing.
I don't think that's that difficult. I mean, when you think of the feats that any animal shows for instinctive discrimination, that's all of a piece with what many animals do. What is not all of a piece is this fact that the same species of cuckoo can mimic the eggs of many different, very different species of egg.
But if I understand the argument in the book, it's a sort of Lorenz-type imprinting argument that the cuckoos who want to go to the reed warbler nest, they're able to find it because they were babies in one.
Exactly, yes.
So it's a whole other layer of complexity, which it isn't that there's a gene so that if you raise a reed warbler gens cuckoo in a lab completely separate and put that out in the wild, that particular cuckoo would never find the right nest.
No, that's right.
It has to do with your upbringing, right? Which, again, it's mind-blowing how this has all worked out.
You're right that it probably is imprinting. Young ducklings, young goslings, for example, imprint on the first moving thing they see after they hatch out. It could be Conrad Lawrence's boots that they imprint on. So it's well known that birds can imprint on early experience and learn about it, and then in later life, they tend to approach it, mate with it, for example. I mean, one of the reasons why zoos have such trouble breeding some animals is that they're imprinted on humans because they were brought up by humans. So yes, imprinting is probably what causes the gens tradition to work. So each cuckoo learns to recognize the nest in which it was brought up. By the way, the most astonishing thing I think about cuckoos, well, perhaps second most astonishing after the egg mimicry, is the way they manage to go on fooling the foster parent when they're hugely bigger than the foster parent.
Yeah.
I mean, they look as though they could swallow the foster parent whole. And yet the foster parent goes on feeding them, entirely innocent of the deception that's being foisted on them.
You're listening to People I Mostly Admire with Steve Levitt and his conversation with Richard Dawkins. After this short break, they'll return to talk about bat echolocation.
If you're a regular listener to this podcast, you know that I'm obsessed with changing the educational system. So I'm definitely not letting Richard Dawkins get away without hearing his opinions on how we should teach science. I'm also curious to hear about the upcoming tour for his new book, The Genetic Book of the Dead. It looks more like a rock star on tour than a book author.
As I've read The Genetic Book of the Dead, I couldn't help but think about the contrast between your books and what I remember of high school biology from my own youth and watching my teenage children take the courses. I still remember kingdom, phylum, class, order, family, genus, species, but I don't think it has ever helped me do anything in life. And in contrast, the various stages of mitosis, I think I forgot those the day after the exam.
Yes.
What gets lost in the teaching of biology, it seems to me, is the miracle of it all, the beauty of it all, how incredible it is that we live in a world of such stunning complexity.
Yes.
But with such absurd regularities, like all mammals having roughly the same set of bones. It seems to me that the primary goal of high school biology should be to instill that sense of wonder. And I'm wondering, you've taught university students, not high school students, but have you thought at all about what and how you teach high school students if you were in charge?
I mean, you're absolutely right. Unfortunately, there are a lot of facts that people do have to learn. Medical students, for example, have to learn a lot of anatomy, and it's very, very detailed. In some cases, you can make a story out of the facts that you have to learn. In my third book, The Blind Watchmaker, for example, I devoted most of a chapter to bat echolocation, sonar, the navigation by bats using echoes. And I managed to string together a lot of facts about the way bats do it by posing a set of problems. So the first problem a bat has to solve is, how do you find a way around in the dark? And I suggested, well, what about having a sort of searchlight? And the problem with that is that its energy is very, very costly, and it calls attention to yourself, that sort of thing. So the solution to that problem is to use echoes. And then, given that you're using echoes, you then have the problem of how do you resolve fine detail? The answer to that is it has to be very, very high frequency, because high frequency means short wavelength, and you need short wavelength in order to resolve the fine detail of the images that you're putting together in your brain. So it has to be very high pitched. Then it has to be very loud, because the echo is necessarily very faint compared to the outgoing cry. That raises yet another problem. And the problem is, if it's very, very loud, that is in danger of deafening you. Well, it's no good reducing the sensitivity of your ears, because then they can't hear the very faint echoes when they come back. So what's the solution to that problem? Well, in some cases, to temporarily deafen yourself as you're giving these supremely loud cries. And some of these bats have a muscle that's attached to their little bones that connect the eardrum to the inner ear. So what they do is they contract the muscle, deafen themselves, then they shriek this phenomenally loud shriek. Then they relax the muscle so that they undeafen themselves just in time to receive the echo. Well, that's, again, a solution to a problem. Now, if you make the story like that, it's easy to remember, because each solution prompts the next problem, which prompts the next solution, etc. That way you don't have to just memorize a whole series of disjointed facts. They're joined together.
I mean, something you do in The Genetic Book of the Dead is you show skeletons of various animals. Like there's a dolphin, a gavial, and something called an ichthyosaur.
Ichthyosaur.
And even though these animals evolved quite independently, when you look at their skulls, you just can't help but think that they eat the same things. Their
Yes.
schools look remarkably alike. I'm actually starting a new and radical high school, so I'm thinking really hard about how I want to teach science. And one of the challenges of teaching a biology course that's about wonder is how do you test mastery? And it struck me as I read your book that showing students a bunch of skeletons and having them see how skeletons match to different behaviors, a great exam question is to show students a new skeleton and ask them what behaviors that creature might have had. Your book was a wonderful goldmine for thinking about the creativity one could bring to both creating a biology class that's fun, but also the way in which you judge mastery.
I'm, of course, delighted to hear you say that. I would love to see my book used in high schools. The chapter you're talking about is about convergent evolution, where different animals who come from different starting points in the animal kingdom converge on the same endpoint, because in the 3 cases you just mentioned, they all eat fish, and you need a certain kind of jaw to eat fish. And the chapter is full of similar examples of convergent evolution. So yes, I think that biology at the school level could be taught in that way.
Your books are full of game theory. Game theory was what first got me excited about economics. And if I were given a choice, I would put a big dose of game theory into high school biology, because I think there are few tools that we teach people that are more useful, both for answering specific academic problems, but just for making your way through the world. But we don't teach it until people are far more advanced. And I don't actually think that's warranted by the difficulty of the concepts.
No, it's not that difficult to understand. I think also statistics, the assessment of risk, probability, these are mathematical theories which are genuinely useful and also exciting and interesting. The idea of analysis of variance, of partitioning variance and explaining why things are the way they are. These are branches of mathematics which are not difficult to grasp intuitively. They may be difficult to actually do the mathematics itself, but I think we could probably introduce that at the school level.
When I read your books, they're about big ideas, but the actual practice when you are a cutting-edge academic, even in your own research on ethology, you tackle much smaller problems, tiny little problems. You began with research on the pecking of chicks, and I found it to be an incredibly brilliant insights that you were bringing to it. But it was chicks pecking. And in general, as young people go from being consumers of knowledge and then become producers of knowledge as actual academics, I think they're often shocked at how narrow they become when they get to the cutting edge and have to focus in so deeply to create insights.
I suppose that's true. And modern research at the cutting edge often is a collective. If you read papers by modern experimental physicists, they often have about 100 authors. So you really are a little cog in a big machine. But it must be a very exciting machine to be a cog in, I think.
Many authors do book tours, of course, but your upcoming book tour is quite extraordinary. It looks a lot more like a concert tour than a book tour. Big venues, you buy your tickets from Ticketmaster. Have you done tours like this before, or is this the first few?
Well, I must say I'm a bit daunted by it. I hope it's going to go all right. I visualize that at each venue I shall be interviewed by a different person, and so they will be the ones to steer the conversation the way it's going to go. So I don't have to sort of prepare a lecture.
Don't you think it's a lot more daunting to be an interviewer than to be an interviewee? Interviewer, you just show up and fine, whatever happens, happens. But I feel a lot of obligation to my guest to try to elicit the best from them. So I feel no sympathy for you as the interviewee, but I feel a lot of sympathy for these interviewers.
I get that. Well, I mean, you've taken the trouble to read the book. I don't suppose all of them will do that. And if I may say so, I've thoroughly enjoyed this interview because you haven't asked the same questions as 100 other people. It's been a stimulating experience for me, and I hope to have the same experience on my book tour.
You know what my fear was? My fear was the end of that sentence was going to be, so if you're available, you know, that we were going to be in
Well, I was tempted
Portland.
to say that. Well, I was tempted to say that.
What are the big, important, open questions in the field of ethology or evolutionary biology that you think we have a chance of answering in the next 20 years that might really matter?
I suppose the origin of life, because we understand the process whereby life flourishes and diversifies and becomes more complicated and better adapted once you've got a replicator survival machine system in place. But how that first started, what the first replicator looked like, it certainly wasn't DNA. DNA is much too high-tech a replicator, as it's been put. So the origin of life is an unsolved question, and it may never be solved definitively because we'll never see it happen. I think the best we can hope for is perhaps a hypothesis that is so elegant that you feel it must be true. So that's one thing. Understanding the brain mechanism, the evolution of brains that can do subjective consciousness, I think is a very major one. Not even sure what the question looks like, let alone the answer. Another thing which would be very exciting if it happened would be making contact with extraterrestrial life and learning how much of the life we're familiar with is unique, how much of it is necessary, how much of it had to be true. I quoted Einstein earlier asking the question whether the universe had to be the way it is. Did life have to be the way it is? Or could life be unimaginably different?
I had so much fun talking to Richard Dawkins today. I didn't want the conversation to end. After we turned off the microphones, we agreed that we'd continue the conversation. I'll be joining Richard on stage at one of his book tour stops at the Warner Theater in Washington, D.C. on September 14th. If you'd like to attend that event or any of his tour stops across the United States, the UK, or Canada, check out the webpage, richarddawkins.com.
Now is the part of the show where I bring my producer Morgan on and we take a listener question.
Hi, Steve. So a listener named Mel emailed us with a question about economic models. She wants to know what your thoughts are on the strengths and weaknesses of economic models when it comes to understanding behavior of real humans.
Human behavior is complicated, and every discipline that tries to study it, whether it's economics or psychology, anthropology, or evolutionary biology, they all have some successes and failures. Stacked up against those other ones, I think economics does well, but there are certainly limitations. Where economics does best is what it was designed to do, to think about prices and to think about incentives and to deal with situations where there's not a lot of emotion floating around, because the whole basis of neoclassical economics is to cut out extraneous things like emotions and human quirks and failures and describe a world in which people act sensibly and reasonably, or in economics terms, rationally.
But Steve, there's a whole discipline devoted to incorporating social interactions and human emotion and flaws into economic models. Is behavioral economics better at predicting real human behavior, do you think?
Well, in the domain of personal interactions, you could hardly do worse than neoclassical economics does. And I'll tell you, I learned that the hard way. My first two really formative romantic relationships were both with economists. And it turns out that if you're in a relationship with an economist, you can act like an economist and things work out pretty well. It was only when I started becoming romantic with non-economists that I realized how completely and totally dysfunctional my economic way of thinking was with regular people. And it took me decades to come around to understanding just how poorly the neoclassical economic model works when you're dealing with regular people. Now, as you say, behavioral economics is an attempt to warp economics, to take into account the fact that people have foibles and they make consistent mistakes. So no doubt, empirically, behavioral economics does a better job at interpersonal relationships. And there's also game theory, of course, because economics has a really hard time with strategic behavior. When people have to react to others, that's not really what our tools were built for. So I think with neoclassical economics and behavioral economics and game theory, you have a really wide set of tools that in practice can explain a lot of human behavior. But the difficulty is once you have such a wide array of tools, all of the art, the skill comes down to knowing which tool to apply. And I tell you, that's not easy. Even the best economists are always trying to learn better how to think about the right tool to pull out at the right time.
often we look to economics to determine what will happen when a law is changed or to guide us in public policy. Do you think it's better in that context?
Definitely. I think economics is an extremely powerful tool in those domains. And there was a time when I would have said, you don't really need anything but economics to figure out the answers to those questions. But as I've gotten older, I've come to appreciate that all of the social sciences, the humanities, have something to say on those decisions. If I were the president, I would certainly start with trying to figure out what the economic model would say. But then I would also be sure to ask a really great sociologist, a really great humanist, a really great biologist, what their views were, because as I've unbrainwashed myself of the brilliance of economics as a set of tools, I've come to really appreciate that a wider view of the world that tries to take on all sorts of lenses is, in my experience, the best one.
Mel, thanks so much for your question. If you have a question or a question for Richard Dawkins, our email is pima@freakonomics.com. That's PIMA@freakonomics.com. We read every email that's sent, and we look forward to reading yours.
In 2 weeks, we're back with a brand new episode featuring Chris Anderson. He's a big thinker who turned the TED Conference from a small, once-a-year gathering into a worldwide phenomenon, with TED Talks receiving billions of views each year. And TED Talks are just the tip of the iceberg when it comes to the ways that Chris Anderson is trying to make the world a better place.
The last time we did this, the total amount raised was just over $1 billion. The amazing thing that happens is infectious generosity. Someone is persuaded and will say, I'm in. And the next person says, well, okay, I'm in too. And ping, 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 ping. In less than an hour, you could suddenly raise huge amounts of money.
As always, thanks for listening, and we'll see you back soon.
People I Mostly Admire is part of the Freakonomics Radio Network, which also includes Freakonomics Radio, No Stupid Questions, and The Economics of Everyday Things. All our shows are produced by Stitcher and Renbud Radio. This episode was produced by Morgan Levy, with help from Lyric Bowditch and mixed by Jasmine Klinger. We had research assistance from Daniel Moritz Rabson. Our theme music was composed by Luis Guerra. We can be reached at pima@freakonomics.com. That's PIMA@freakonomics.com. Thanks for listening.
So she went into the garden to pick a cabbage leaf to make an apple pie, and passing through the street, the great she-bear popped its head into the shop window. What no soap, so he died.
The Freakonomics Radio Network, the hidden side of everything.
Stitcher.